Hello dear audiences, this is the second part of the probability and statistic. Previously on this lecture we discussed about the measure of the tendency. We talk about the mode at the end of the lecture. We discuss about the concept, and in this lecture we continue our discussion. Previously I promised to construct the chart like this nice shape over here, but we didn't have a time enough for preparing that type of the thing. I hope that today we can do this one as well. So let us take a look at the contents that we have it. First of all, we want to talk about the median, another type of the local measures, and before discussing about that one, we should talk about the different types of frequency and how can we construct it. Here you can find the definition of relative frequency distribution, and cumulative and relative cumulative distribution. Let us discuss about these things on a shape and on one table. Then we can find the differences between them and how can we calculate them. So if we take a look on a picture, let me just show the picture for you. Okay, here we have the picture of the discussion. So we have classes, as you can see over here. The classes are given, and based on the information that we have it for 20 up to 30, 30 up to 40, 40 up to 50, and 50 up to 60, we have classes over here. And the related frequency are given. So this table up to this point constructed based on a given information. For example, we have 5 numbers between 20 and 30, 6 data between 30 and 40, and 1 data between 40 and 50, and 2 data between 50 and 60. It's as the same as a previous example on the last lecture. So for calculating the cumulative frequency that we denoted by FC, the cumulative frequency, we should add or sum the frequency previously on that case. Means that at the beginning, for the first class, the frequency and the cumulative frequency are as the same. As you can see, they are both as the same. For the next one, we will add 5 by 6 and it becomes 11, and then the next cumulative frequency gonna be 11. Means that when we discuss about the cumulative frequency, or f of c, this f of c, if I just write it f of c of I, it's as is equal to summation of fj. All the frequency that the j is before the I. J is less than equal to I. We can use this formula to calculate the cumulative frequency. Means that, for example, if I want to calculate f of c of 2, f of c2 means that for the second class we want to calculate the cumulative frequency of a second class, then it's gonna be as equal to f1 plus f2, the first frequency added by the second frequency. It can be true for the remains. Means that f of cumulative for the next one will be 11 plus 1. 11 is added by 1 and it became 12. When we discuss about the cumulative frequency, for instance, at the third class the cumulative frequency is 12. Means that previously for this class the addition of all frequencies 5 and 6 and 1 is equal to 12. For the next one, as you can see, again I just added by 2 for the next frequency and the result is 14. Always the addition of the frequency and the last cumulative frequency should be the same, because we have that much of the frequency at the end. It looks like a dam. If you just consider a water, if you have a water here, the different type of the waters that we split the water with some with some dam over here, with some obstacle. So this looks like a frequencies. This is f1, the first frequency, the second frequency is f of 2, and the third frequency is f of 3. And when we discuss about the cumulative frequency, means that we add them. So for the first case, f of c of 1, or the first cumulative frequency is as the same as here. For the second one, we add these two frequencies to calculate f of c of 2. And for the third one as well, we add the first three frequencies to find f of c of 3. So in this way we can calculate the cumulative frequencies. So for the remaining part, for the relative frequency, the name is obviously determine the meaning of that one. Means that we have a relative frequency here, and we should calculate the relation between that frequency and the whole frequencies that we have it. For example, over here we have the relative frequency. The first frequency is 5, so the division of 5 over all frequencies that we have it is 14, so 5 over 14 will be that frequency. For the next one is 6 over 14, the next one is 1 over 14, and the next one is 2 over 14. So it's only enough to divide each frequency by the total frequencies to calculate the relative frequency. So if we just take a look over here, there is some advantages and disadvantages for this one. For example, when we discuss about the frequency of one class, for example 5 only, without knowing the total frequency, when we know only the frequency over here, it's not give you any information about the whole or entire population. We just know that the first frequency is 5, the second frequency is 6, or so on. But we don't get any information about all entire space. But when we have a relative frequency 5 over 14, we have some idea about the whole space as well. Means that the frequency of that class over 14, the total or the entire frequency, give us two information. One is about the frequency of that individual class. The second one is the information that what is the relation between the frequency of that class with all or entire space, means 5 over 14. The another problem that we have it for the relative frequency, we talk about the benefit of using relative frequency, but there is some weak points as well. For example, if you have 6 over 14, this 6 over 14 can be simplified as a 3 over 7. So we have two type of a notation over here. There is no differences between 6 over 14 and 3 over 7. But when we discuss about 3 over 7, it doesn't mean that the frequency of that class is 3 and the whole space is 7. So it's only give us the information that what is the ratio of occupied data in that class in comparison with all space. So this 3 over 7 still give us some information about that one. And the last part is a relative cumulative frequency that we denoted by f of c of r, the relative cumulative frequency. So the relative cumulative frequency, as you can guess about that part, is calculated like this. The first relative cumulative frequency is as the same as a first cumulative. For the second one, we add 5 by 6, and then it's gonna be 11 over 14, and again we do the same thing, means that we add them and we cumulate them, we sum up the values to calculate the next step. And always the last class has a relative cumulative frequency of 1, as the same as the addition of them at the relative frequencies. So this is a table of frequencies. Let us take a look at the median of the given data, the raw data, and also the cases that we have a frequency table. So here we go. The median, and how can we find the median value? First of all, when the data are given, we are looking on a data and we sort them from the smallest number to the biggest one. So it's very important in most of the cases that the student made a mistake. It's because that they didn't sort the data. First of all, we sort the data means that we just take a look on it and we sort them such that the smallest one located at the left and the biggest one, the greater one, will be on the right. Then the middle number, which is 15 over here, gonna be the median of these numbers. So for instance, if we have 3, 5 and 12, as you can see, it's sorted and the 5 is in the middle, so it's gonna be the median for these values. So it's important to understand the location of a median. For finding the location of a median, we have this formula, means that we just add the number of a data by 1 and divide it by 2 to find the location of the median. So let me just take a look on this example closely over here. So as you can see over here, we have several data. First of all, when the data are given, for instance, this set of data are given here, 1, 4, 7, 9, 12, 15, 17, 23, and 44, 56, and 60. First of all, we count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 data are given. So n over here, or the number of the data, are 11. So it's important to understand that the data are sorted from the smallest to biggest. If it's not, you should sort them. When the number of the elements are 11, then first of all we will find the location of median. Location of median, or LMD, the location of median, is equal to n plus 1 over 2. N plus 1 means that we have 11 and we add it by 1 and divide it by 2. 11 plus 1 over 2 will be equal to 6, means that the location of median is equal to 6, means that the 6 elements over here, 1, 2, 3, 4, 5 and 6, the 6 elements over here, or 15, will be equal to our median. So we find the median and the location of that one is equal to 6. Right now, if the elements, the given elements, is located between two elements, for instance, if the number of a data, the number of given data is equal to 12, the next example, we have 12 elements. We have 1, 4, 7, 9, 12, 15, 17, 23, 44, 56, and 60. And at the end, we add 77 to that one. So the number of the elements over here is even, is equal to 12. Right now, when we want to calculate the location of median, then the location of median over here is equal to n plus 1 over 2, and this n plus 1 over 2 means that it's equal to 6.5. Right now, it means that the location of median should be between the 15 and 17. This is the 6 elements over here, and 17 over here is the 7th one. So the elements that we have it over here is between 15 and 17, means that it's denoted that the median is located between 15 and 17. To calculate the median, we have two ways right now. One way is calculating the average of 15 and 17, which is equal to 16, and we add them and divide it by 2. The another one, which is better than the previous one, is like this. If I consider the 6 elements over here, this is the 6 elements, I just write it over here separately. So this is the 6 elements, which is 15, and the 7 elements over here is 17. This is 17 at the place or at the location of 7. So it's the 7th elements, which is 17, and the 6th one is equal to 15. And as I said it before, the median located in the middle of them means that half of a length should be traveled from 15 and half remains to the next one. The place that we find it, the location that we find it, was 6.5. So to calculate the median right now, I just started from the location 6, means that it's equal to 15, and then I add the half of the space between them. Means that we just calculate the half, this is the half, multiplied by 17 minus 15. So the differences between the sixth element and 7 elements is 17 minus 15. This is the distance between them. So this distance is equal to 2, and we should go half of that distance to reach to this point. So I add half of a distance between the differences between 17 and 15, and the differences between 17 and 15 is equal to 2. Of course, half of 2 is 1, so the number that we have it over there will be 16. This method of calculation helps us to calculate the quartiles easier than the other methods. So let us take a look at the case that we should calculate the median for a frequency table. So if the frequency table is given, then to calculate the median we do the same thing. I remind you that when you just have the table like this, the frequency table, this frequency table, it's equal to talk about this raw data. Means that when the frequency is 5 for the class between 20 and 30, means that for the class mark of 25 we have a repeated number of 25 5 times. Means that 25 are repeated 5 times. We have 25 over here. Let me just grab it and put it again here. So 25 means that 25 is repeated over here 5 times. This is 4 times, and one more we should put it here, so we have one more 25. And for the next step between 30 and 40 we have frequency of 6, and this frequency of 6 means that 35, this number is repeated 6 times. And if we consider that one 35 and we repeat that number over here 6 times, then we can put it here. So this is 35 and again 35, and it's repeated 6 times over there. So let me just grab both of them and repeat them. It's easier to just repeat it. So this is the 4 time of this one, and this is the 6 times, and between 40 and 50 the frequency is equal to 1. So over here we have 145 as well. Let me just put 45, and 2 times 55. So we have 2 times 55, so this is 55, and one more 55 should be considered here. So this table is equal to this type of the raw data. To calculate the median over here, first of all we should know the n. And what is n over here? N is the addition of all frequencies. Means that I should add all of these frequencies. This frequency over here, the addition of frequency are given over here as 14. So the frequency, the addition of the frequency is 14. So we have 14 data over here. As you remember, we should calculate the location of median, and to find the location of median we should add the addition of them. Means that 14, the number n, plus 1, and we divide it by 2. So the result will be 7.5. So means that the location of them will be 7.5. Or if we count them over here, it will be the first, second, third, fourth, fifth. This is the first frequency, and the 7 location is here between 35 and 35. Means that the location of median should be somewhere between these 35. And how can we just do this one with the frequency table? So for finding the place of them, we use the cumulative frequencies. So when the cumulative frequency is greater than the given location, over here is 11, and 11 is greater than the location of median, then we consider the class mark over there as a median. Means that over here the median should be equal to 35. So this is how can we find the cumulative the median based on a cumulative frequency. So let us take a look on another local measurement. When we have some data, like the data that is given at this example, then if we sort them, it's very important to sort the data. As you can see over here, the data are not sorted. So in a first step, when the data are given, we sort them. So we have 2 as a first number, then 4, then another 4, then 5 and 6 and 7 and 8. There are the numbers that we have it here. So these are the given data that we sort them from the smallest one to the greatest one. So when we just have this one, the first thing is dividing the number to 2 parts. If we just consider the 5, 3 number will be remains at the right and 3 number at the left. So the 5 gonna be the median. This is the median over here, that we can consider it as a second quartiles. Means that the second quartiles is as the same as the median. Then we divide these numbers to 4 parts. So if we divide it to 4 parts, then this gonna be the splitting part. As you can see, in the middle of each line we have 1 digit. So 2, 4, 6 and 8 are in the middle over here. So we divide this we divide this data to 4 parts. This is 1 part, this is the second part, this is the third part, and the fourth one is at the end, and they are as the same. The lengths of each of them are as the same. So the Q1 or the first quartile located over here, and the third quartile will be there at the point 7. So we have the first quartile equal to 4, the third quartile equal to 7. So to find them, if we have several numbers of quartiles over here, to find the place of them, we have the similar formula. Means that this is the location of Q1, the first quartile. To find the location of Q1, we just have this formula that we add the number of the data by 1 and we divide it by 4. Because it's a quartile, we should divide it by 4. N plus 1. Number of the data, for example, over here is 1, 2, 3, 4, 5, 6, 7. So we have 7 and we add 7 by 1 and divide it by 4, which is 2. So the location of the first quartile will be the second location. So the second location over here is 4. So the first quartile, therefore the first quartile over here is equal to 4. For the second quartile or for median, we have the same formula. I mean, the location of Q2 or the second quartile is as the same as 2 times of that number. Means that 2 times by the value that we have it over there, n plus 1 over 4, and 2 times by n plus 1 over 4. After cancelling 4 and 2 and simplify them, it will be equal to n plus 1 over 2. Is as the same as a location of median. We calculate the location of median previously with that formula. Means that this is as the same as a location of median. Means that the second quartile is as the same as median, and by the number over here, 7 plus 1 over 2 will be equal to 4. For this case is equal to 4. Means that the location of second quartile is 4. 1, 2, 3, 4. The fourth location over here is 5. So the second quartile or the median is equal to 5. And for the last one, the location of Q3. The location of Q3, for calculate the location of Q3, we have the same formula. Means that we have 3 times right now, 3 times by n plus 1 over 4, and we calculate n plus 1 over 4 previously. So this n plus 1 over 4 was equal to 2. 2 times 3 is equal to 6. So this is the 6th location. I emphasize about this formula. This gives you the location. So the location over here is 6, and the 6th location is gonna be the number 7. So the third quartile will be 7. So if we have a digits for the location, then what we're gonna do, this is the question. So how can we calculate the quartiles when the location are not the complete digits like this? Let us take a look at that case. So as you can see in this slide, we have the formula. We discussed about this formula before, that how can we find the location of Q1, location of Q2, which is as the same as location of median. And right now we have this data, and again we should sort them. Fortunately, the numbers that we have it, the data that we have it, are sorted already, so it's no need to sort them again. And right now let us count the number of the elements, or the n over here. N over here is 1 2 3 4 5 6 7 8 9 10 11 12. So the n is equal to 12. Let us start by calculating the location of Q1. As you can see, the location of Q1 is as the same as n plus 1 over 4. And n over here is 12, so we should calculate 12 plus 1 over 4. And 12 over 4 is 3, so we have 3 plus 3.25. 3.25. Right now, this should be the location of the first quartile. But what does it mean that the location is between 3 and 4 and it's 3.25? Let me just write the third number over here, which is 7. 7 is a third number. This is the third location. And the fourth location over here is 9. So the number, the quartile, should be a value between 7 and 9, but it's not exactly in the middle of them. So indeed, the location that we find it over here is 3.25. Means that the value of the first quartile is between the third location and a fourth location, but the place of them is 3.25. Means that 25% it should be closer to 7 than to 9. So to calculate the Q1, or the first quartile, we just started with the first number. First number over here is 7. Then we add 25%, or 0.25, to the differences between these two numbers. So 0.25 multiplied by 9 minus 7. The differences between them is 9 minus 7. So 9 minus 7 is 2. 2 times 0.25 is half, and we have 7.5. So this is the first quartile that we can consider it over here. For the Q3 also we have the same thing, and again location of Q3 is calculated by this formula. So it's going to be 3 times of the previous one, means that 3 times 3.25. So it will be 9.75 over here. And if we consider that location, we should look at the 9 and 10 one. 1 2 3 4 5 6 7 8 9 and 10, means that it should be a value between 44 and 56. So again, if I just consider the number over here, 44 and 56, as I said it, the number that we have it here is 44 and 56. This is the 9th location. I will write 9th location here, and this is the 10th one over there. This is their location in a sorted data, and the place of a third quartile is 975, means that it should be a value closer to 56 than 44. So to calculate Q3, if I want to calculate the Q3, so I should start it with 44 again, the 9 location. Then the place, as I said, it is 0.75 over here, means that this distance is bigger than the previous one. So I add it by 0.75 times the differences between the 10th and 9 elements, means that 56 minus 44, and then I can calculate that value. So So we can see the calculation over here, and we will find the Q3 as I said it by that value, which is equal to 53. The another things that we have it here is IQR, or intermediate quartile range, and that's important to understand the meaning of these things. So indeed, if we consider the data as a value that are ranged in one line, and it's ranging between these two braces here. So we divide the data to 4 partitions. So this is the Q1, it determines the Q1. This is the median, or Q2, which is located exactly in the middle, and we have Q3, which is located over there. And the intermediate quartile range determine the differences between Q3 and Q1. Indeed, this value, this IQR, determine the main part of the data. So the another thing that is important over here is the outliers. So it means that some data are irrelevant to this type of the given data, means that it's not related to them. So for example, if you just consider the example that we had it 1, 4, 7, 9, 12, 15, 17 and so on, if we had at the beginning one data like minus 1000, so as you can see, this minus 1000 is totally irrelevant to this data. It's totally too smaller than the others. The other data are totally close to each other, but that minus 1000 is somehow has no relation between that number and the other data. So we should somehow omit that data or neglect that value from the given data. So how can we decide about this type of the thing? It's gonna be the outlier. So what does it mean? Let me just show you over here. So over here you can see that if we consider one range over here, means that 1.5 times more than IQR over here, so 3/2 or 1.5 IQR if it's added by Q3, or if I subtract this IQR, 1.5 IQR from Q1, means that before this one, if I add subtract 3/2 IQR over here, then I can find the outliers. So for example, in this case, the IQR is calculated at 45.5. And 1.5 of 45.5 I calculated over here. It's gonna be 75.75 or minus 15.25. If I subtract this 1.5 IQR from Q1, or if I add 1.5 of IQR to the Q3, then I will find 75.75 and minus 15.25. Means that over there, this value after Q3 is given by 53. If you add 53 by 1.5 or 3/2, 1.5 of 45.5, which is the IQR over here, then the value based on that calculation will be 75.75, as I remember. Yes, 75.75 means that if the value is bigger than 70.5.75, then that one should be neglected. If we have that one over there, based on that one, yes, based on that one, it should be neglected. Also, if the data is smaller than 3/2 of IQR, it means that if I subtract Q1, 7.5 minus 3/2 of IQR over there, IQR is given by 45.5, then I should neglect the number which is smaller than that value, and this determines the outlier of the given values, as I said it over there. So the another thing is a measure of variability. So let me just talk about that one now. So to understand the standard deviation and why do we need the measure of dispersion, it's a good example to start with these two group of data. For example, assume that we have two group of data. One of them is given by -1, 0, and 1, and the another group of data is given by -100 and 0 and 100. So I just use the simplest case of data that we can have it over there. So let us call the first group of a number as a group of A. Let me just write it over here, group A, and the second one is a group B. So let us calculate the measure of local measures for the both of them. If we calculate the x bar, or the mean for the first one mean is 0, the second one means is equal to 0 as well. If we calculate the median of them, and simply you can see that the 0 is in the middle, it's sorted, and for the second one is 0 as well. So if we calculate even the mode over there, the mode over here is there is no mode because it's not repeated. Any of data are not repeated more than the others, and for the second one is as well. So as you can see, for both of this group of data, the local measures are as the same, but you can see the differences between them. Means that if I assume the real line over here, then if I only locate the points over here, the 0 is there, and if we can consider the 1 here and -1, this is the first value, but for the second one it's 100 and -100 as well. For the second one, you can see that the data are totally splitted from the center. Means that for the first one the differences between them is too small, but for the second one the data are too far away from each other. How can we distinguish between the group A and group B? And as you can see, all the local measurement are as the same. So here we need another type of the measurements that determine this dispersion, determine this separation over here. So for this reason, we have the range of the data that we discussed about it before. The range is the x max minus x mean. For instance, for the second group, the range is equal to 2. For the second one is 200. And as you can see, there is one difference between these two data with one type of the measurement that you can see over there. The another type of the measurement over here is the standard deviation. We determine that one by s square. So before that we calculate the s square, let us take a look at the data. One type of the separation is looking like this. To determine this separation, we need to know that how much the data are separated from the mean. For the first value of a data, you can see that this data is one unit separated from the mean, which is 0, and the another one is 1 unit as well over here. But the value over here is -1 and the right one is 1, and the addition of them is 0. It means that if we calculate the separation of a data, means that we want to know what is the differences between x bar and xi, and as you can see, we want to calculate this xi and x bar, and it's nice to calculate the summation of them. Means that we want to know that what is the addition of this separation, and we take we take the mean or average of this separation. So let us see that what is the value of this one if we calculate it over here from I equal to 1 up to n. Let me just write it here. So if we calculate this value, as you can see, the separation is 1 at the 1 unit at the right and minus 1 unit at the left, and the addition is 0. Does it equal to 0 always? This is the question, and I want to answer to that one. So if you just take a look over here, I can rewrite that summation as a summation of x bar over n minus summation of xi over n. So I can write these things like this because it's a property of a summation, means that I can split it. It's like adding two numbers. It's a associative property of adding the numbers, and it's a property of real numbers indeed, that I can split them and write it as a two summation. And the second summation over here is too familiar for you. I mean, it looks like a xi over n, and if you just calculate xi over n, is equal to x bar over there. So if you just take a look over here, you can find out that this summation of xi over n is as the same as it's as the same as x bar, and we have the x bar at the left as well. So this x bar is not related to the n index, so I can write this x bar out of that summation. Then I have sum over here, sum of let me just write it over here. As you can see over here, this number inside of summation means that 1 is remained, and this x bar is not related to the n, so it's coming out, and the n is at the bottom, I equal to 1 up to n. I should emphasize about these things that this n is totally outside of the summation, means that we divide them. Let me just put the division longer to determine that this n is outside of this one. So summation of n minus x bar. And as you can see, if you add one n times to itself, it's going to be n, and this n and n will be cancelled from the numerator and denominator of this one, and the result is equal to 0. So as you can see, the deviation, the addition of a deviation is equal to 0. To avoid this problem, we just square the value, means that instead of writing that one, we can calculate the s square or the standard deviation as following. Instead of writing that one, we just write it as a x bar minus xi. Again, we have this separation value, but instead of, to avoid this problem, we square it. If we square that one, or if we put the absolute value, we can put the absolute value, but the value is called the different things over there when we put the absolute. So if we just write it over here, this xi minus x bar square, and right now we divide it by n, then we will find the standard deviation. So to calculate the standard deviation, we can calculate this value. On the other side, we can simplify this formula as well. How can we simplify it? Indeed, instead of writing that value, we can expand this expression and write it like this. Means that we can start it by this one, s squared, that we talk about it was equal to summation of x bar minus xi, as I said it, x bar minus xi, and we square it, and we divide it by n. Right now, let us expand this one, and using the Newton formula for this one, means that it's going to be summation of the first one square, x bar square, then the second one square, means that the xi square, and minus 2 times of the first one times second one. This is the formula that you learned it in high school, so it's very simple, means that it's a first formula in algebra. So we divide this value by n at the end, so we split them to two parts. Indeed, I just use this formula that the a plus b square is equal to, you may know that one, let me just write it here. Okay, to summarize the things, I just wrote it over here. As you can see, we can expand it by using this formula, the algebraic formula that you learned in high school. And after that we expand it, we just split it to 3 parts. As you can see, this x bar is splitted and divided by n, the second one as well, and the third one. So we split them on 3 parts. So x bar square is not related to the n, so it's coming out from the summation. It's not related to that one, and the second one and the third one, and in the third one also this x bar is not related and coming out from the summation. So the second formula that we have it is the average of squares data, means that xi square, we average the x squares over here. We denote it by x square bar. So it's the average of square data. And in the first one, the addition of number 1 n times will be n, and this n from a numerator and denominator will be omitted, and the remainder will be x bar totally square. For the second one, this is the formula of the mean or x bar, and we rewrite it over here, and at the end we reach to this formula. Later on in expected value also we will reach to similar formula at the end. So this formula help us to calculate the standard deviation easier. Let us calculate the standard deviation for both cases to show that how can we do that one. As you can see in this example, we have some data over here, and to find the standard deviation we should do as follow. As you can see, the data are given here. First of all, when the data are given, we calculate the mean of the data by add them together and divide it by the number of the data. The mean is equal to 124.3. So after that we find that one, then we can calculate the differences between x and x bar, and for each data we should do it separately. For 123, for example, over here we have 123, we have 123, and differences between 123 and 124.3, which is the mean, is equal to minus 1.3. You can see minus 1.3 over here. Then we square all of these values, and add them together to find the average of them as a standard deviation over there. So when we have the square of that value, we call it the variances. S square is a variances, and if we take a roots of that one, means that the roots of s square over there will be equal to s, or a standard deviation. This is the differences between the s square and s. And one thing more that you can find it over here is the denominator. The denominator is given by n minus 1. Indeed, for the raw data, for the data which is splitted, which is not in a table, we use n minus 1 at the denominator. And accept this one from me right now. Later on we will discuss about that things. So because we want that the data will be unbiased, we need to put n minus 1 instead of n. This is the only differences that we have it with this case. And when we have a table of a data, so if we have a table of a data, what shall we do? Let me just do that one as well to show you how can we calculate it. I emphasize about them again that when you have a data, first you should find their average. When you find the average, means that you add all of these numbers and divide it by 10. Then you will find the differences of each data by the average that is listed over here. You square it, and then you get the average of them, but with one difference is that you put n minus 1 at the denominator. If the data are given as a split values, it's not given by the table. So what we're gonna do for a table, let me just show you that one as well. So this shows the calculation for a table. When we have a table of a data, then we can use the formula that you can see over here for the variances. Means that over there we have a class mark. The class mark just replace with the data that we have it over there. First of all, we calculate fi xi to know what is the average. When you add all of this fi xi together, it's going to be this value, and by dividing this value by n you can find the averages. Then we calculate the xi minus x bar, which is the differences between each element and x bar. Look at it, the addition of them is like this, and you divide it by 100. Then the x bar from here, you can find the x bar, or mu. For the table we use the mu. Mu is equal to 67.45, so we divide it by 100, so it's going to be this value. Right now we subtract this value from a class mark, means that this 61 minus 67.45 will be equal to minus 6.45 that you can see over here. Then we square all of this value. We square the first one, the second one, the third one, and at the end we multiply them by fi, multiply them by their frequency, because it's repeated as much as fi times, and at the end you will find this value over there. So for calculating the variances at the end of the day, you can divide the value by n minus 1 to show what is the variances, and by taking the roots of the variances you will find the standard deviation as well. So another thing that is remain to discuss is about how can we sketch or plotting the diagram for the given data. Let us assume that this frequency table is given. Then to sketch the histogram diagram, we put one gap at the beginning of a x line to show that the data is not exactly started from zero. It's the important thing that you put some gap over here to show that one. Then we just put the border of the classes. It's started from 20, so I just put 20 over here. The next data that we have it is 30. The next data is 40, 50, and 60. We just put them over here, and then based on their frequency we try to sketch some rectangle at the top of each part. Means that we just sketch that one based on their frequency. The frequency of the first one is 5. Let me mesh the y line as well. Let me just do it right now. So right now, based on a frequency, I just sketch some rectangle. For the first one, as you can see, the given height is 5, the frequency is 5. Let me just sketch it here. It's 5 here. The next one is 6, so it's one more over here, so I should sketch the next one over here. This is the 6, and the next one is 1, so I should sketch it like that. And another one is 2, so the height will be 2 units. So based on this one, we sketch the histogram diagram. To sketch the polygon diagram, I just find the midpoints of them and connect these midpoints to sketch the polygon diagram. Means that I just use the last one as well. So this is the class mark indeed. When I just choose the midpoints, is 25, the class mark of the first one. So based on this one, I just connect these points together to sketch the polygon as well. So means that I sketch this line as well, I connect these 2 points as well, and the remains over here. So I just sketch them like this. Right now I have a polygon as well. The pie chart as well can be sketched in a similar way by calculating the value for the degree in a pie diagram. Let us take a look on it. So for the pie diagram or pie chart, we started by sketching a circle and one line over there. Then we multiply the relative frequency of each class. For example, the first class has a relative frequency of 5/14. We multiply this 5/14 by 360 degree, which determines the total degree of one circle. Means that we multiply by 360 degree, and when we calculate that one, it will be equal to 100 129 approximately. So this 129 will be the angle for the first part. So this angle should be 129, and the remaining one should be considered in a similar way as well. I mean, for the second one, you multiply this value and next value as well, and based on that one, you can have a chart. So another type of the chart that is important is an Ogive graph. This Ogive graph, it's written like this, Ogive graph. For writing this Ogive graph, we use the class mark in an x line and cumulative frequency or relative cumulative frequency for the y line. So for instance, over here at 0.25, which is a class mark of a first class, the cumulative frequency is 5. So 1, 2, 3, 4, 5. I just noted over here. The another one is 11, means that 6, 7, 8, 9, 10, 11. This will be the second one. For the third one is 12, one more here, and the third one is 14, which is here. Always this type of the graph is increasing graph. So if we connect these points together, then it will be the Ogive graph. So this is the first one, the second one, the third one, and at the end of the day, I just connect them to the last one, 25. One previous class could be considered as 15. So I just connect that points to the 15, which is a previous, which we can consider it as a previous class. This determines the Ogive graph as well. You can take a look at that type of the graph and plotting graph on a PowerPoint or Excel or any file. Let me just show you on Excel over here. So if you just take a look at the Excel file, let me just choose one points over here, then you can find the insert over here, for instance, at the PowerPoint, and over here we have the chart as well. So if you just take a look at the chart, you can find the pie charts by putting the information. You can sketch that type of the nice graph as well, and you can find the line graph. It's like a polygon graph that I talk about it, and also the column one, which is the histogram graph, that you can find it with the different visions and different shape of graph. So later on we will discuss about the scatter of x and y for the regression at the end of this course indeed. So I hope that this hour of a lecture was useful for you. Thank you for attending.